What is a matrix and how does matrix multiplication work? You may be familiar with the movie The Matrix. What a matrix is a row and another row, etc. of data. Then if I have a list of numbers like 2, 3 and 4, 7, then this is a matrix because it has this row, and they're contained inside these brackets. So that's a matrix with 2 rows and 2 columns. So matrix multiplication, it's one of the main operations used in artificial intelligence. Dot products are the most used typically, and matrix multiplication is basically groups of dot products. So how does matrix multiplication work? If you have matrix A, matrices are usually written in capital letters to show that they're a matrix, whereas dot products are written with lowercase letters. So have matrix A, and say it consists of 2 rows and 3 columns. So just say 2, 7, 1, 4, 5, 9. So here's the first row, and here's the second row. And then they're contained inside brackets. At the beginning of the matrix is a bracket, and the end of the matrix is a bracket. Okay, so now if I have matrix B also, see matrix B is equal to, say 1, 2, 3, 5, 6, 7. Do this. All right, so here's one row and there's another row. So put brackets around the beginning of the matrix and the end of the matrix. So this is a matrix that consists of 2 rows and 3 columns. The columns, one way to picture it is like columns that hold up a coliseum. They go up and down the columns to hold up a building. And so going up and down is a column. It typically goes in the order of rows and columns. I picture a car, an RC car. The RC is row column. So the rows first and the columns second. So how this can be described is rows of columns. So there's 2 rows and 3 columns. So this would be called a 2 by 3 matrix. And so that's how you describe the shape of the matrix, is 2 by 3. All right, so now we have matrix A and matrix B. So if I'm going to matrix multiply, then different symbols can be used for matrix multiplication. One common one is just placing them by each other, like in algebra where you just place 2 variables by each other, and that means multiply. So if you have AB, that means matrix multiply A with B. So if I matrix multiply A and B, then I would transpose B. So the symbol for that is the capital T in Python, or in PyTorch at least. So B dot capital T. So B dot capital T, it would take the 2 rows and 3 columns and turn it into 3 rows and 2 columns. Way to do that is picture the first row gets rotated to the right by 90 degrees. So 1, 2, 3, that's the first row. It becomes the column. So that's 1, 2, 3. Then the next row gets rotated by 90 degrees to the right as well. 5, 6, 7. So 5, 6, 7. Okay. So now we have 1, 2, 3, 5, 6, 7. So each of these gets a bracket set since each of these is a row, and then the outer bracket for the whole matrix. Okay. Now B is transposed. So then A, what it'll do is take the 2, 7, 1 and rotate it by 90 degrees to the right as well. Multiply the 2 with the 1. So 2 times 1 is 2. So I'll write down intermediate parts here. So 2. So 2 times 1 is 2. And then 7 times 2. See, it's the second element up here is multiplied with the second element down here. So 7 times 2 is 14. So you add these, plus 14. And then move to the third element here, which is 1, and multiply it with the third element going down, which is 3. So plus 1 times 3 is 3. Okay, so 2 plus 14 plus 3, that's 16, 17, 18, 19. Okay, so the first element is 19. First element of the matrix multiplication answer. Okay, next we'll take the same first row in matrix A and rotate it to the right again and multiply it with this column. Like if you notice the pattern, like complete this row first with all of this. So this is rotated to the right and it was multiplied with this column. Then that same thing is rotated to the right and multiplied with the next column. And so you do that for however many columns it is. So 2 times 5 is 10. So 10. And 7 times 6 is 42. So 42. And 1 times 7 is 7. So 7. Okay, now 10 plus 42 plus 7 is 10. It's 52. 52 plus 7 is 59. So 59 goes here. 59, comma. Okay, now this first row is complete. Then, now that this one's done, we can mark that out, ignore it, and move to the next row in matrix A. So 4, 5, 9, and just follow the same pattern as you did with the first row. So 4, 5, 9, so 4 times 1 is 4. 4 times 1 is 4. 5 times 2 is 10, so plus 10. 9 times 3 is 27, so plus 27. And add those together. You have 4 plus 10 is 14 plus 27. Let's see, 10 plus 27 is 37 plus 4 is 41. So we have 41 goes here. And again, use this same row, the 4, 5, 9, and matrix and rotate it 90 degrees and multiply it with this again, or multiply it with this second column. So 4 times 5 is 20. So 20. 5 times 6 is 30. So plus 30. And 9 times 7 is 63. So plus 63. So 30 plus 67. Oh, sorry. 67. 30 plus 63 is 93. And add 20 to that is 113. So let's see. A different way. Add it. 63 plus 20 is 83. 93, 103, 113. Yeah. So 113 is the answer to that. And then put brackets around that. Then put the opening and closing brackets to complete the matrix. And there is matrix A, matrix multiplied with matrix B. So that is how to do matrix multiplication in artificial intelligence. So I'm going to open a Jupyter Notebook and show how to do that in Python. So new file, Jupyter Notebook. All right, so import torch for PyTorch. Whoops, TORCH. Okay. Use the base environment. Okay. So imported torch, or it's importing torch. That's done. Now I'm going to make matrix A is equal to 271 459. Okay. Oops. So that's matrix A. Matrix B is 1, 2, 3, 5, 6, 7. Okay. Matrix B is 1, 2, 3, 5, 6, 7. All right. So now we have matrix A and matrix B, but I want to convert them to a tensor, but I want to convert them to a torch tensor. So torch dot tensor. That's simple enough. And put these around them, and then here torch dot tensor. Put this around them. Okay. I'm gonna scoot this over so it looks better. There. And scoot this one over so it looks better. All right. So now we have matrix A and matrix B. Now to matrix multiply them together, just simply put A and the at symbol B. That's one of the ways to do it. So whenever I run this, it should show the same result as this: 19, 59, then 41 and 113. 19, 59, 1. It should show the same as this: 19, 59, and then 41 and 113. And go. Oh, I didn't transpose it. Dot capital T. Okay, and now run it. 19, 59, 41, and 113. 19, 59, 41, and 113. So that's how you do matrix multiplication in artificial intelligence. And that's probably the most used calculations in AI. It's the most computation used. So if you see, like, the basic y equals mx plus b in graphing a straight line, in neural nets, you might see that y hat, or the prediction, in other words, is equal to, instead of mx plus b, it's wx plus b, or sometimes it's written x, or in this case it would be xw plus b, if this is a matrix of the inputs and this is a matrix of the weights. So, and the b is the bias that's added to it. So that is the main operations used, or those are the main calculations used in artificial intelligence. And this is how you do them. It actually consists of dot products, or dot products are just say if I do this, then I would element-wise multiply these and add the results. So 2 times 1 is 2, 7 times 2 is 14, 1 times 3 is 3. So 2 plus 14 plus 3, let's see, 2 plus 14 is 16, plus 3 is 19. So that would be 19 as a result. And so that would be dot producting A and B together. It would actually be lowercase, typically written in lowercase by the convention. So, or A dot B. Oh, and remove these outer brackets. Forgot about that. There. If I run it, there's the 19. So that's how to do dot products, and dot products combined together is what matrix multiplication is. So remember, grab this first row and rotate it 90 degrees and matrix multiply with the transpose of B's, or the transpose of B, the first column that results of that transpose of B. And so notice doing 2, 7, 1 multiplied with this element wise. So 2 times 1 is 2, 7 times 2 is 14, 1 times 3 is 3. And that equals the 19 up here. And so notice how this equals 19 as well, when it's the 2, 7, 1, 1, 2, 3. So grouping together dot products is one way to think of what matrix multiplication is. So that's how matrix multiplication works in artificial intelligence. If you have any questions or comments, let me know. And thanks for watching. Please click like and subscribe.